What I want to do here is I want to do a quick review of lesson 78. It's not a review, it's kind of a preview. And what we're dealing with in lesson 78 is rational functions. All right? Rational functions are functions that are written like this. Y equals 2 over x plus 3 minus 1. What makes it a rational function? What do we usually think of when we hear the word rational?
Makes it true?
No, not true. Rational doesn't mean true in mathematics. What are the rational numbers? Numbers that can be written as fractions, right? So a rational function is a function that has an x in the denominator of the fraction. If it has a variable in the denominator, it's a rational expression, okay? So that's what makes this a rational function. So if you have x in the denominator, that's what rational function means. So what I want you to think of when you think of rational functions, it has an x that should be in the denominator. Now, we spent a lot of time in previous units looking at what happens if you have x in the denominator of a fraction. All right, we spent some time in this unit simplifying expressions that had x's in the denominator, right? And we spent some time in previous units determining things like this. If we had an expression like, not x, what was that? What did I just have? Was it 5 over x minus 3? 2 over x minus 3 minus 1. We spent some time talking about what x cannot be. What is the excluded value of x in this expression?
3, positive 3.
My goodness, Mac, you act perturbed by my question. It's 3! Idiot! Oh, just kidding. I know you didn't say that, Mac. I'm not saying that you imply that.
I really don't understand what that other word means.
X cannot be 3. Right? Why can x not be 3? This is not the answer. This is the answer to the question I just asked, which is what is the excluded value for x? X cannot be 3 in this expression. Why can x not be 3 in this expression? Because we can't have 0 in the denominator. Division by 0 is undefined, right? 0 under the line is undefined. We can't have 0 in the denominator of a fraction. All right, so if I extend this to this function, if we take back and write this same thing in function form, f of x equals 2 over x minus 3 minus 1. If we do that,
You went forward or backward?
then we have, let me see if I can undo that.
Okay, yeah.
If we do this, f of x equals 2 over x minus 3 minus 1. Remember, f of x is just a fancy way of writing y equals. F of x replaces y. It's function notation. X can still not be 3, right? Can x be 3 in this expression? No, x can't be in this equation. X can't be 3 in this equation because x can't be 3 in this expression, right? In function form, we give it a different, kind of a different value or different definition. X equals 3 is really, and this is not math terminology, really bad. Not bab. It's really bad. Okay?
Didn't we already kind of get that?
Yeah, we already kind of got that. But it's so bad in function form because the reason we put things in function form is for graphing purposes. Okay, something on the graph really bad happens at x equals 3. We can't plug 3 in there. If we plug 3 in, it breaks the function, right? What happens there is that x equals 3 is what we call, y'all ready for this? New definition, a vertical asymptote.
We still haven't actually figured out the problem.
What do you mean we haven't figured out the problem?
What were we supposed to figure out about that problem? Oh, wait.
The example is that x equals 3 is really bad. X equals 3 is a vertical asymptote. Okay? It's a new definition. Vertical asymptote. All right? Is everybody okay with this?
Sure.
Now, working with the same example, I'm going to clear this off, but you guys, we still have the same example. You don't need to write this again. 2 over x minus 3 minus 1. That's the same function that we're working with. In this expression, this part right here can never equal what?
3.
X can't be 3. This part as a whole can never equal what?
0.
It can never equal 0, right? Why can it never equal 0? Because the only way you can make a fraction equal to 0 is if the 0 is where?
On top.
On top. Can that 2 ever be 0?
No.
Okay? That 2 can never be 0. We can't put 0 on the bottom, and if we did, that still wouldn't give us 0. That'd give us something bad. So this part of this expression can never be equal to 0. All right? Now, y'all watch me with this. That means that f of x, this part, which just replaces what variable? What variable is there? Y. Y can never equal 0 minus 1, which is negative 1.
That's the answer?
I'm building a point here. The answer is irrelevant at this point. We're examining this function. We're not working toward an answer. So far we have 2 restrictions here, don't we? What are the 2 restrictions we have?
0 and 3.
X cannot equal 3. And watch this, what we just found. Y cannot equal negative 1. You're so worried about what the answer is, Mac, you're missing the point of what we're doing here. Y cannot equal negative 1. All right? There's 2 restricted values. There's a restricted value for X. There's a restricted value for Y. Okay? Now, it just so happens that the restricted values of X and the restricted values of Y are always going to come from the same place in a rational function that's in this form. And on this next test, the only thing we're going to look at are rational functions in this form. Okay? Now, what we've developed so far is that x equals 3 is a vertical, right, asymptote, P-T-O-T, strange word. Guess what y equals negative 1 is? Y equals negative 1 is a horizontal asymptote. Now, we're not going to look at the graphs of these at this point. We're kind of rushing through this. The only thing I'm going to ask you on the next test is to identify the horizontal asymptotes and the vertical asymptotes. That's the only thing I'm going to ask you. Y equals negative 1 is a horizontal asymptote. Okay? So, next example. And this one's more of an example that we've kind of developed our concept at this point. Let's have a look at what a problem might look like on a test. See what you guys can do with it. The directions are going to say, find the asymptotes.
Basically, it's excluded values.
That's the excluded values. That's exactly right. But we're going to express them a little bit differently than we do excluded values, and I'll show you what I mean by that. And here's the function. F of x equals 3 over x plus 7 plus 4. f of x equals 3 over x plus 7 plus 4. What can x not equal?
-7.
X cannot be -7. Okay. What can y not equal?
0.
No. This part can't be 0,
4,
which means y cannot be
-4.
positive 4.
Oh.
If this part right here can't be 0, the only way y could equal 4, remember f of x replaces y. The only way y could equal 4 is if this part is equal to 0. Can this part equal to 0?
Never.
Because this part right here, this part can never equal 0, y can never equal 4. All right? So, those are the two excluded values. The way we want to express our answers, though, what are we trying to identify? Asymptotes. X equals -7 is our vertical asymptote. And let's just use phi A for this point, right? Y equals 4 is the horizontal asymptote. So all we're doing is finding these excluded values. Next, after spring break, we're going to come back and revisit this concept a little bit and look at the graphs. What does these vertical and horizontal asymptotes have to do with the graph? All right, let's look at one more, and then I'm going to give you the formula. F of x equals -7 over x plus 4 minus 3. Find the asymptotes for this expression. I have no idea why I keep hitting something that does that. I can't even remember what it was now at this point. F of x equals what? Y'all help me out.
F of x equals -7 over x plus 4. So -3.
Thanks, Gray and gang. Plus 4 minus.
So x can't equal -4.
Right. So the excluded values, x can't be -4. No, it's not +3. This cannot be 0. This thing right here, this piece cannot be 0, which means y cannot be whatever this is. It's always that number. Okay? Because the only way we could get -3 is if this expression over here is equal to 0, and it can't be. It could be 3. Can -7 over x plus 4 be 6? Sure it can. We could find a value for x that would make that 6, and then 6 minus 3 would give us 3. The only thing that we can't find is a value that would make this equal to what? 0. That can't be 0, and so we could never have 0 minus 3, which means y can never be 0 minus 3, which is -3. So our vertical asymptote is x equals -4. Got to be x equals. It's an equation of a vertical line. It has to have a variable. Horizontal asymptote has to be y equals -3. So that's how the problem would be answered. The asymptotes come from the excluded values in the expression. All right?
All we need to know.
That's it, buddy. Here's the formula. You ready? The formula is f of x equals a over x minus, I said x and wrote h, x minus h plus k.
Why don't we use B and C?
Do what?
Why don't you use B and C?
You know, whenever you go to, this is called, loosely, this is a vertex form of this. H and K are always used. So we'll see more H and K's as we move into next chapter. We'll see H and K, or actually Unit 10, there's H and K in the quadratic expressions. So H and K, they're just variables. Actually, they're parameters. The variables are X and Y. A, H, and K are parameters, and they do specific things to the function. We'll examine the graphs and look at that. We know what h does, right? What can x not be in this expression? H. So x equals h is our vertical asymptote. Y equals k is our horizontal asymptote. Now I want you to notice that from the formula to the solution, h changes signs. You got a negative in your formula, it comes out as a positive, right? K does not change signs. So whatever the sign of this number is the sign of this number. And we saw that in our previous examples, right? So we're changing the sign of x, we're not changing the sign of k. All right, that's the assignment from lesson 78. Any questions before we move to 79? All right, 79. Stop this.